Okay, hi Mr. Dixon. This is gonna be my test questions for test number 2, and I got number 2 wrong, so it's okay. So 3 stones of different masses, so it's 1m, 2m, and 3m, are thrown vertically upward with different velocities. So they're throwing upwards with different velocities. And the diagram indicates the mass and velocity of each stone rank from high to low. The maximum height of each stone. Assume air resistance is negligible. So this is 1m, this is 2, and this is 3. And rank the high to low maximum height of each stone. Assume air resistance is negligible. So if the height is higher, then that means it will have a higher velocity. So arrow 3 will have the higher velocity due to the height. And this rank 1 will be, so I just have to correct the arrow, make this a little bit higher. This one might go up a little, and then this one is down. So this one will be lower because the velocity is lower, so therefore the height will be lower. So my answer will be C, which is 3, then 2, then 1. Okay, that's number 2. And I also got number 4 wrong. Okay, let me get my equations out for number 4. Okay, so number 4, it says a rock is thrown straight up with an initial velocity of 18.6 meters per second. How far will the rock located after 2 seconds? So your initial velocity, your initial velocity is V0. So V0 will be 18.62 meters per second. This is number 4. And your time will be 2 seconds, because they give you the time is 2 seconds, and acceleration is negative 9.8 meters per second. So with that given this, you're gonna use the equation, this one, because it's also gonna use delta x equals v naught t plus 1/2 at squared. Okay, so you're given v naught, so you're gonna plug in 18.62 meters per second. Then the time would be 2 seconds plus 1/2 acceleration negative 9.8 meters per second square, and time will be 2 seconds square. Okay, so you're gonna solve for delta x because it is being thrown up straight. Okay, that. So you have this, okay. You have this equation, you're gonna plug this in the calculator. So I'm gonna get a calculator. So first I'm gonna do this. So this calculator. So do 18.62 times 2, so you get 37.24 meters because your seconds will cancel out. So you have that, and then you plus, so then you put this second one. So we do 1 divided 1/2 times -9.8 times 2. Wait, hold on. Actually, you do, this is 4 seconds. You do that first, and then you do 1/2 times -9.8. So you do you have -4.9 meters per second square. So then your seconds will cancel out. So then you would do 37.24 plus parentheses -4.9. That times, so you get 17.64 meters. That would be D. 17.64, 17.6. So that would be D. Okay, and number 5. Oh, this is so inky. Okay. Number 5, a rock is thrown straight down with a velocity of 14.3 meters per second from a cliff. So you have a cliff, and a rock is here, and you're throwing it down. What is the speed after 3.0 seconds? So you know your V0 is -14.3 meters per second because you're going down. So it's being thrown down as you go negative. And your time is 3 seconds. Acceleration will be -9.8 meters per second. Yeah. So you have your V0 time, acceleration. So the equation you will use is V equals V0 plus AT. So your V0 is -14.3. Wait, actually 14.3 meters per second plus A is -9.8 meters per second square. Time is 3 seconds. So you just plug that into the calculator. So I'll do -9.8 times 3. So you get -29.4. Seconds will cancel out, so you have meters and per second. Meters per second, because so seconds cancel out. You still have 1 second left. Plus 14.3 meters per second. So you would do 14.3 plus -29.4. You get wait, actually, I messed up. I plugged it in wrong. So you do 14.3 plus -29.4. Wait, that is wrong. I did something wrong. I messed up somewhere. Hold on. Wait, to velocity. That, okay. Negative. Oh, okay. Oh, I see what I did. I forgot to put the negative. Whoops. Because this is negative and I forgot to put the negative here. Okay. I plugged it wrong. Sorry. Negative 14.3 then plus -29.4. Okay, then you get negative, okay, then you get, let me see, then you get negative 34.7 meters per second. And this is negative because your ball is thrown downwards. Okay, that's negative. So my answer will be D. 43.7 meters per second. Okay, that's number 5. Oops. And then I got number 6 wrong. So a bottle with a note is thrown horizontally with top from the top edge of a cliff. It has initial speed of 11 meters per second. So your initial speed, your V naught, is 11 meters per second. Messenger counted 4 seconds. Your time would be 4 seconds. And how far from the cliff's edge does the bottle travel horizontally? So your acceleration will be negative 9.8 meters per second square. Okay. So with this given information, you will use this equation. Delta x equals v naught t plus 1/2 8t squared. Delta x because it's thrown horizontally, so that'll be your x value. For x. This will cancel out, be 0. Because you don't need this. And there's no acceleration acting on x. So this will be 0. So what you will do is you plug in v naught, so 11 meters per second times t is 4 seconds. So that multiply that, you'll get 44 meters. Seconds will cancel out. You have 44 meters. And my answer will be 44, which is B. Yep. Okay, and then I got number 8 wrong. Okay. A projectile is fired from the surface of Earth with a speed of 200 meters per second at an angle of 30 degrees above the horizontal. If the ground is level, what is the maximum height reached by the projectile? So we have a picture. So 200 meters per second. So your V naught is 200 meters per second. And then you're trying to find the maximum height. So maximum height will be this is your y, this is your x. So the maximum height will be your y. So you're trying to find the maximum height of how high it will go. So your V naught will be 200 meters per second. Your V naught y will be 200 sine 30. Oh, your angle is 30 degrees. I forgot that. Use V naught y sine because sine is for x and cosine is for y. I'm looking back at my notes. Yeah. Yep. Okay. So you would plug this into the calculator. So you do 200 sine 30. You get 100. 100 meters per second. Okay. And with that equation, with this given information, you're going to use the equation Vy square equals V naught y square. Oh, sorry. to use this equation. Plus 2a delta y, because you're trying to find delta y. So what you do is, since you're trying to get delta y by itself, you divide by 2a. You get, did I do this wrong? No, actually, this is supposed to be minus, not equal. So then you get vy squared minus v naught y squared equals delta y. Divide this by 2a. That, okay. Okay, get this. And then you're gonna plug in what you have. So your vy squared is your delta y is, because let me rewrite this over here. So delta y equals vy squared minus v naught y squared over 2a. So your delta y is 0 because you don't know, you're trying to find your delta y. Your vy squared will be a 200 sine 30, and then your 2a will be 2 times acceleration negative 9.8 meters per second square. Plug this in the calculator, so you get, this will be 100 because you get this 100 meters per second right here. And then you do 2 times negative 9.8, negative 19.6. So you do 100 divided by negative 19.6. You move the decimal, you get 510.2, which is approximately 500. Okay, so this will be 500. Yeah, so it'll be 500 meters. This is 0 because you don't know the height. That's why this is 0. Yep, so that's number 8. So number 10, which of the following pairs of graphs best represents the vertical components of the velocity and acceleration v and a respectively of the ball's trajectory as functions of time? Up is the positive direction. So the time, acceleration, and velocity relates. So there's 4 graphs. And so when velocity is negative, is going down, your acceleration has to be constant because acceleration and velocity and time relates. So like this one goes down, they all go down except for C. C goes up, so that would be wrong. And so then this one, when the velocity goes down, acceleration increases. That's not right. So this one, acceleration goes down. Velocity goes down, acceleration goes down. Acceleration has to be constant. So therefore, it will be A. So number 10 will be A. Okay, number open-ended. Number 1. Okay. Starting from one of the main kinetic equations, derive the equation for the time it takes the projectile shot at an angle theta to return to the ground. So when you shoot something, this is one open-ended question. Oh, okay. So, so when you shoot something up, wait, hold on. Wait. When you shoot something up, the y would, you shoot something up, it doesn't have an angle, so therefore it will go back down to the y. So you would use the equation delta y actually you don't know your that, so you would use this one because you don't know your delta y. Okay, so you would derive the equation to get the time. So you're trying to find t, so you're going to move the v naught y to the other side, so that cancels out, and so you get 0 minus v naught y equals 1/2 at. Okay, after that, to get rid of the 1/2, you multiply the whole equations by 2 so that it can cancel out. So you're left with this. So you have 2 times 0 minus v naught y equals at, and you still have t, right? So you're going to use sad mep, which is the reverse of PEMDAS. So you would divide first to get t, so you get divide by a. That cancels out, so you get t equals 2 minus that over a, because this one will cancel out, it'll be 0, so you don't need that. So this would be the answer after you derive the equation to find the time. So that's number 1. Number 2, I got it wrong. So this is 1. Number 2, find the maximum height for a ball shot vertically on Earth 200 meters per second. So when you're shooting up vertically, it'll go up like this. So that'll be your y. Okay, so you know your v naught would be 200 meters per second because that's when it starts. It goes up, so you have 200 meters per second. Acceleration will be negative 9.8 meters per second, and time would be, you don't know the time because you're trying to find the height. Find the maximum height, so you don't know the time. So what you would do is use the equation v equals v naught plus at, that, because you know v naught, a and t, so your v naught will be 200 meters per second plus negative 9.8 meters per second square, and your t. Wait, actually, I did it wrong. Okay, never mind. Ignore what I did. Sorry. You're trying to find t, so first you derive the equation. You derive the equation, so you move the v naught over. So you minus v naught. So v minus v naught equals at, have that. And you divide by a, that cancels out. So then you plug in what you have. Yeah. Okay, so your v will be 0 minus v naught will be 200 meters per second over a is negative 9.8. And so this will be negative 200 meters per second over, oh shoot, I forgot my meters, that. So what you do is plug that in. So you do negative 200 divided by negative 9.8. Right? You get 20.41. Yeah. You get 20.41. And your seconds will cancel out. So you will have 20.41 meters. And that will be the time that it will take if it's the height. Yeah, so that's that. And then number 3, I got it wrong. I only did a part of it, but I used the wrong equation to do the problem. Find the coordinates of an artillery shell that explodes 39 seconds and if it's shot at 300 meters per second at 55 above the horizontal. So, okay, so draw the picture out. So this will be 55. Let's see. So you have 55 angle and it's shot at 300 meters per second. Yeah. So draw that, shoot that. Okay. Where's the number? Okay. So you would need to find the x and y component. So what you would do is you would do the x, you would break it up into 2 components, your x and your y. So this is your x, this is your y. Okay. So your x you would use 300 because that's it's shot at 300. Then your x it would be cosine 55, and then your y will be sine 55. Okay, so then you plug that into a calculator. So you would plug in 300 cosine 55. You get 172.1. And then you do 300 sine 55. You get 245.7 meters per second. Yeah. Okay. Get this. After this, then you would solve for the x and y, because after that it's broken up to x and y. So you would solve for the coordinates x and y. So what equation you would use is x minus x naught equals v naught t plus 1/2 at squared. This will be delta x. Okay, so this will be your x component, and then the other one will be y. Wait. So what you would do is this will be delta x, same thing, equals v naught t plus 1/2 at squared. Okay, so the 1/2 at squared will cancel out to be 0 because there is no gravity acting on the x. Okay, so that'll be 0. So you have delta x equals v naught. Your v naught is from here, the x.